Let's go.
All right, 4 o'clock. Thank you for joining us. We're going to kind of go a little bit quick. This session is titled From Zero to Backend in 45 Minutes with Eclipse VertX. My name is Jeremy Davis. I'm a Principal Solutions Architect at Red Hat, and I'm joined by
Jim Tyrell. I'm a Senior Principal Solutions Architect at Red Hat. Been there for almost 12 years.
And I've been there for almost 10 years. So we've been around Red Hat for a while. First things first, I mentioned that we're going to go fast. We're not kidding. In preparing for this talk, we came up with roughly 7 hours worth of material. We've distilled that down to 45 minutes, which means we're going to need to go really quickly, just like Mr. Wolf drove in Pulp Fiction. So we weren't kidding about prizes, so shoot your questions out. We're happy to take questions. We might table them till the end. If we are going too fast, raise your hand, yell, tell us to slow down, right? So first things first, Red Hat productized VertX just recently. The way that Red Hat works, all of our engineers commit code to community projects. And VertX has been a community project since
2011.
Since 2011, right? So it's been around for 7 years. We just made it a product, meaning we have a release that we support and that we patch and keep maintained for longer periods of time. And we also have consulting and things like that around it. So I wanted to set about learning VertX. And what's the best way to learn something or learn a new technology? Where do you always start when you learn a new technology?
Hello world.
Right? Not hello world, right? Because hello world is awful. Hello world is awful for a number of reasons, mainly because hello world always works, right? Like, hello world always works, you never have a problem with it, and therefore, in my opinion, you learn absolutely nothing, right?
Doesn't talk to databases, isn't production ready.
Right, exactly. It's completely useless, it always works, makes you feel great about the technology, but it doesn't tell you what it's going to be like to really use the technology. So I wanted a real world application to build, right? Now, if you're like me, you've probably done this and you started your own little pet project application and it went nowhere. If you're like me, it goes nowhere, right? Ends up just like hanging out on GitHub or something. So I was Googling around looking for a real world project I could build with specs, and I found a project called literally Real World. And it's by these guys at Thinkster.io. This is a really interesting website. What they built out, and they have tutorials for their application. They built out this application that's a clone of Medium, the blogging platform, that's called Conduit. So this is Conduit at production ready. No, my internet's not going to go down right now, is it? Please. Okay, so we can sign. We can sign in. I guess we signed out or signed in here. That's their live version. What the application is, though, they've got an API, a JSON API, that's in between lots and lots of different front ends. And their API is running live, so you can just go to their API and get results of their API. You can see this is the articles coming back. So you can build this out. You can build out any front end. And if you want to try out any of these technologies, you can just clone these technologies and pull them down and look at these to learn, right? So you want to look at React Redux or Vue or Aurelia. JavaScript changes pretty fast, right? There's a lot of different front ends. There's also a lot of different back ends. VertX is really great at building out APIs. It's one of the things that's really useful for it. We hear about it a lot in terms of microservices. It's also really good at traditional web design and API design. So I decided to build this in VertX. There is, by the way, a guy who beat us to it. So last month, somebody else built a VertX version out. So you can take a look at theirs and compare, see who writes better code, which means we're really on the hook now to deliver something reasonably impressive here. So their APIs are all documented here. There's largely two sets of APIs in the application, mostly either around users or around articles. So we have, post requests for users, registering users. We'll start with the registration of users because that's kind of a logical place to start. Can you guys see that font okay? And they tell you, for example, on registering a user, they're going to post JSON in this format, and it's going to return JSON in this format. And then they give you a set of Postman tests. Is everybody familiar with Postman? Anybody not familiar with Postman? If you're not familiar with Postman, this is a really great tool. Check this tool out. But they have a whole suite of tests you just pull in, and we can just go to the test and run it. So let's say we want to get all articles. We can just fire that off, and I'm talking to the wrong URL. So I'm talking to my local URL. But I come in here, change this to their URL, we fire this off, we can get the live one. This is set to my local one, so we'll be running this during our presentation. So this is a real-world application, and I decided to build this in Vertex and find out where those like sort of rough edges were, where those edge cases were, and we found a couple of them that we'll talk about in here. Another thing is that I liked about this real-world application, I'll go back to, I started at JBoss about 10 years ago. My first conference talk I gave at Boston in 2011, and I was talking about the advantages of building completely separate front-end and back-end applications tied together with a JSON API. Right, so this is an idea I had for a long time. So naturally, I saw the Thinkster guys like this same architecture, which of course means they're geniuses because they agree with me. At the time, I thought this was a better way than doing like JSF or JSPs, right? I think that really clean separation. You let the web guys be the web guys, you let the back-end guys be the back-end guys, right? So this has been something that's kind of been a favorite of mine for a long time, which also meant that it was a reason that I wanted to implement this application.
So if you go back in history, oh, where's the microphone? Am I good? Yeah, you guys are, oh, there it is. All right, there's the feedback. So if you're familiar with the HornetQ project at all, anybody familiar with that one? It's a JBoss JMS implementation that started back a little bit before I actually joined Red Hat in 2007, or right in that time frame. Tim Fox was the founder of that project, and over the course of a couple of years, he realized that he essentially rewritten the JMS project at that point in time, released what was HornetQ, and massively increased the throughput of that messaging technology at that point in time. You can see that in some of these charts. If you go forward to the back-end architecture, so one more forward, Netty is a core part of that architecture. Anybody familiar with Netty at all? Anybody buy anything in the Apple iTunes store? A few people there, right? So Netty is a core part of the back-end of a lot of very high-performant web properties that you probably are interacting with, like the Apple iTunes store. It uses the NIO, or the NIO architecture for asynchronous communication to basically ensure that your processor isn't pausing while it's doing blocking for I/O like we've traditionally done in a lot of Java applications, right? So the core part of Vertex, at least at its lowest levels, is leveraging this Netty library to make it as fast as possible. And it's been developed at JBoss since 2004 and gone through several iterations over time, and it's a core part of a lot of technology we ship.
And then right after HornetQ was finished, Node.js came out, right? And Node.js ran a single-threaded event loop using an NIO, non-blocking I/O architecture, right? And so Tim got the idea that maybe he would take what he'd done inside of HornetQ and expand on that. And he had left Red Hat and gone to work for SpringSource at the time, and he started the Vertex project, came back to Red Hat a little bit later. Today, he's at Google. The Netty project, which began life at JBoss, two of the guys are now, one of the guys is now at Twitter. Twitter uses Netty heavily, and one guy's at Apple, working on the Apple Store. And then we had some open source intrigue, right? So we made the press here. Who controls Vertex, right? So there was some drama involved. Anyway, back to Red Hat, and now Red Hat guys are the leads on Vertex. And as you might have guessed,
hosted at the Eclipse Foundation.
Hosted at the Eclipse Foundation,
Yep.
right? So it's a neutral party that hosts Vertex. It's really, really fast, right? It's even faster than we're talking and presenting today. But as its origins from a guy who likes to make things that were really small, really lightweight, and really fast, right?
And it's used in a lot of different places. So this is just a list of some of the logos of people that have talked and blogged about this. One that's not up here is T-Mobile. They've spoken at our Red Hat Summit extensively about their use of this internally. And what people are talking about is its performance, right? Against some of these other programming models that we've done with Java EE and now Jakarta and MicroProfile. With that non-blocking I/O, a very lightweight programming model centered around doing things asynchronously, you get massive amounts of performance. And then, if you're interested or curious about it, lots of different YouTube videos from various conferences, two or three books that are available for free from developers.redhat.com. And as we talked about, if you go forward one more, there's the brand new book that was just announced this week for early access. With that code up there, you can get a 50% off. And for the best question, we will buy one for you at the end of this talk.
Yep, for the best question. Actually, any question that this guy deems worthy of that book.
I'm sure he takes bribery.
It could be more than one question, right? So if he thinks your question's worthy, you get a copy of this book. No pressure. Now, a little bit about Vertex. So we mentioned earlier that the notion of a non-blocking event loop. So it's similar to the way that Node.js has an event loop. Vertex will spin up more than one event loop, but it runs on a single-threaded event loop that's going to pull in any interaction. So when you make a web request, it's going to grab your request and then throw the processing off to a different thread. That's going to be a key thing when we start looking at some code. The rule is don't block the event loop. Second sort of key point, verticals do all the work. In a Vert.x world, you will write verticals. Verticals can spin up other verticals, and they can do all of the work. They will do all of the work inside of Vert.x. We will be using pretty standard verticals and standard stuff in here. You can spin off blocking verticals called a worker vertical. In fact, we're going to be using Mongo, because Mongo is really cool and it uses JSON. It's really fast and easy to develop on. If you were using a more traditional data access paradigm, like say Hibernate, you'd spin that off into a worker vertical because it might block a thread, right? So you can absolutely use those kind of tools. You just need to take a little care for it. And then, as may not be surprising from a guy who got his start writing a JMS message broker, an event bus is core to Vert.x. Now, this is not like an event bus that you have to spend a lot of time configuring or worry about persistence. It's nothing like that. This is simply the way that verticals talk to one another. In fact, this little piece of architecture is exactly what we're going to build. We're going to build a web server, HTTP server vertical, and a database vertical, and they're going to talk to each other by sending messages over an event bus. It's really, really easy to configure, though. So some of the other things to keep in mind as we're about to start coding here, we're running out of time, we need to really start coding. So Vert.x is modular. It's super tiny, lightweight core jar file, and then we're going to bring in some other pieces that are all pretty small as well. There's tons and tons of modules. We're going to look at like Vert.x Web, a module for talking to Mongo, for handling authentication and authorization through Mongo, JWT, all sorts of stuff. Second piece, JSON is a first-class citizen. In the reactive world, we were talking about reactive with some people before we got going here. The notion of sending messages from component to component is highly encouraged. JSON is a great payload for that message bus for a number of reasons. One, we're not pushing objects that might have a reference in memory across from place to place. Second, we can also talk to the event bus externally. So we could write a JavaScript client and talk to the event bus. So step first, we're going to quickly create a project, right? So there's two ways to quickly create a project. And I'm going to start off. Can you guys all see my font? Is this big enough?
A little bigger.
Little bigger?
Yeah.
All right. Let's go to profiles. Let's go to text. That's going to be pretty big.
Yeah, that'll work.
All right, so I'm on my desktop. Let's make a directory. All right, and now for the sake of going quickly, I'm going to copy and paste most of this instead of live code it, mainly because I wasn't able to live code this fast enough. First way we can really quickly spin up a project, let's make a new directory. Maker, Vert.x conduit. Is we can run a Maven command, right? And this is going to build out very obviously a Maven project in a Maven project format, right? So let's go to my desktop. So code one, we got a Vert.x conduit, POM, XML, right, what you're expecting. And we have a main and a test, right? So we have a main vertical and a test vertical. That's one way we can build things out. I prefer this other way of building things out. I don't really know why, but I do. There's a starter project on Git, so you can just clone this project. So
You need to remove that directory. There you go. This pair programmer didn't help him out, I guess.
yeah, there we go. All right, so we've got this is going to have a little bit more in here. So we've got our source and our POM. We've got a couple of things here called redeploy. That's going to come in really handy. But we're going to make a couple of adjustments really quickly here. So let's open up this folder. And then we could do this in VIM, right? But I'm just going to go really quick, use this because I think it's easier to see. Why is that not happy? File, open.
It's a little different than
Desktop.
Got to go all the way down to your folder with a file.
I want to open that
There
folder.
you go.
All right, so inside this folder, we're going to update our POM file. So we're going to change the name of our project package from IO Vert.x starter to IO Vert.x code 1 conduit. and we'll call our project Vertex Code 1 Conduit. And I'm going to change my starter vertical here to Code 1. Code 1. Catch those typos.
Glasses time.
Code 1 Conduit. Now I mentioned that Vertex is modular. We only have one module here right now, or two. Sorry, we have two. We have two modules.
There you go.
There we go. Vertex Core, which you can see right here, and then Vertex Unit, which wraps JUnit. Right, so those are our two modules at the moment. The one other thing I'm going to change here is this redeploy. Code 1 Conduit. Now we will go ahead and import this project into IntelliJ. So project from existing sources. So what do you got? Do you guys use IntelliJ, Eclipse, Code? Visual Studio
IntelliJ,
Code?
put your hands up in the air. Eclipse. Wow. VS Code. A few people. All right. Something else? Vim, BBEdit.
Is anybody crazy enough to still be using like Vim or Emacs? No. Okay.
VI. Absolutely.
Absolutely.
It's all those escapes. It's a lot of escapes.
And then let's just refactor the name of this package. Rename package. Code 1 Conduit. And we have, load file system changes. We have a main vertical and a test vertical. One other thing to do inside of our directory is get rid of our git directory, right? So rm-rf.git. All right, so our main vertical is a very tiny, simple Vertex application that does almost nothing. But it's going to spin up and it's going to say hello Vertex. I promise we weren't doing hello world, right? Oh, hello Vertex, though.
So you basically lied to everybody at the beginning of the talk, Jeremy?
It doesn't say world.
Oh, all right. Works for me.
And then we have a base level test that we get right here. It didn't import that. It didn't change the package. Code 1. Come on, IntelliJ.
Yeah, that is weird. In rehearsal, that worked every time until the prior rehearsal.
Yeah.
Yeah, oh well. Yeah, the trailing dot there, yep.
Okay. And here's a test. This test is just going to grab a client and it's going to call a base endpoint and make sure it has a 200 level response, right? So if you run that, it's not going to be real exciting or anything, but we have a green bar. And then that redeploy thing that I changed, let's take a look at what that redeploy thing does.
Need SH tab. There you go.
Yeah. So the redeploy thing is going to build our project and spin it up, and then it's going to watch to see if we make any changes, right? So it's going to make sure we say,
Go to the browser first.
oh yeah, let's go to the browser. Hello Vertex, right? And it's going to say, we're going to save that off. We can look over there, see it's building. It's going to put our new vertical up. And we have hello code 1. So especially when you're building a website and making changes like this, using the redeploy shell script is really nice and easy. We'll turn that off. And if we want to see too, if we want to do like Maven clean package, it's going to build a fat jar. Anybody using fat jars? Familiar with the concept of fat jars, right? Everybody?
A few people.
Okay.
All
Yep.
right.
So what it's building out here, we get a regular jar and a fat jar. I like using the fat jar. So our target, we get Vertex start project dash fat.jar. So we can just spin that up. We get the same thing, right? So we can just say Java jar target dash fat jar.
How big is it?
I don't know. Small. It's already booted
It's a pretty
up.
tiny fat jar.
Pretty tiny fat jar.
6 megs, but now, so far I have the best question, so I get the prize. I'm kind of hoping that it'll spark the prize.
There we go. Yeah, that is. You have the best. Well, I already gave you your water bottle back, so it's.
But he didn't want based on his inability to know he lost it.
All right. So what we just looked at. We very quickly used the Maven Vertex plugin. So we can use Maven to create this from Maven, or we can use GitHub. So the next thing we're going to do, we're going to start developing our application. And being good developers, we're going to start by writing a test case first, right? So let's create a test case. if we look at our API, the thing that makes the most sense to me to start developing first would be, where's our API? Would be the register user case, right? So we'll post a request to API users. We're going to give it this JSON as a body, and we're going to expect that this JSON comes back, right? Pretty simple test case. We're going to build that out here. We'll go new Java class, register.
While you're typing that, how many of you do test-driven development where you write test cases first before you actually write code? Wow.
How many people write test cases?
Okay, that's better. But you do it after the fact? Or when bugs are filed, then you write a test case like, oh, I didn't think of that case.
So first, we're also going to add these modules in here. So we've got the Vertex core module. Right below that, I'm going to put Vertex web and Vertex web client. So web is, as you notice, we already were spinning up a very minimal web server, but Vertex web is going to give us advanced routing and the ability to handle, stuff that's coming over our request. And then Vertex web client has two uses. One, it's very useful if you're calling other endpoints, right? Common thing inside of both websites and microservices. It's also really great inside of our unit tests because it makes it really easy to test, the endpoints that we're writing. And then I mentioned I'm going to cheat here and copy and paste this because I'm probably already running behind. I have a pretty good feeling. Sorry? I'm sorry?
I can't hear it. A little louder. I can't hear the question. Sorry. A launch error in the redeploy script? Launcher.
Oh, yeah. It launches the main method of the class. So it launches the main vertical, which is our main vertical right here. All right, so now we've got this, this test case written. Let's take a look at what we've got here for our test case. So first thing to notice is a little strange. We have a run with, right? If you're familiar with the JUnit 4, there is JUnit 5. It's still in beta, so I'm using JUnit 4 here. We have a Vertex unit runner, and that's going to wrap our JUnit test and help deal with the threading issues, because Vertex is going to run on multiple threads. So we're kicking off a JUnit test. That's in one thread. Then we're kicking off a Vertex event loop in another thread, and then other threads to do the processing. So it would be very possible, it's very easy for a JUnit to finish executing before work is actually finished, and there's a couple of constructs here that will help us to mitigate that. Wrapping it with Vertex unit runner here is one of those things. One of the other things is this test context here that we have. So we pass into all of our methods a test context, and then we're spinning up our Vertex, spinning up our web client that we'll use, and we're deploying a new vertical, which I haven't written, so this won't compile at the moment. And then inside of our test method, we have an async. We get an async from our test context, and that's just going to say, we're not done until we tell you we're done, right? So keep the thread open, wait for stuff to happen until I explicitly say we're done. So one of the other big key things I said to mention was that JSON is a first-class citizen, right? So what we're going to create here are JSON objects. We're creating two JSON objects because under the covers, Vertex uses Jackson to parse your traditional Java objects. It makes it very easy to just take a Java object or a POJO that you have and turn that into JSON. But the API that we're using is a little bit interesting in that it wants a user with a dependent object of the user, right? It doesn't just want to see users. Part of the reason I wanted to do a real-world application is to find edge cases. How do we deal with this, right? So we create this user JSON, and then we wrap that inside of a user, and then we use our web client here to post that request to API users, to this endpoint. We then send our JSON object, and we have other send methods. Can you guys all see that okay? So we send our JSON object, we pass in our JSON, and then we pass in a Lambda, right? So in reactive programming, often we write a method that does something, and then we send it code to execute on completion, and that's what we're doing here. You'll see this notion of AR or asynchronous result as a common naming convention inside the Vertex world. And if this succeeds, then we just do a lot of JUnit-like stuff, right? We're just going to assert things. And then otherwise, we're just going to fail. So I can't compile this yet because I don't have that class. So let's create that class. Created our HTTP vertical. Actually, I should create our user object to deal with that first, shouldn't I? We'll create the vertical and then create our user object. We are passing around a user object, so it does make sense to create a domain model. So this is what a little more complex vertical than our main vertical, right? We have we're still creating an HTTP server down here, but we're passing in a router. And I've created 2 routers. If you've ever used, like in the Ruby or Flask kind of world or JavaScript world, this kind of concept of a router is pretty familiar. I'm creating a base router to handle everything at the root level here, and we're still returning hello Vertex. We'll change that to hello code 1, right? And that will allow us to still have our root level document. In a real application, this would allow us to maybe serve some web pages dynamically this way, and then put everything else behind this URL API, right? Because the spec that we're coding to expects everything behind this /API. So I'm also creating an API router. And my API router, I'm passing everything with user.star is going to my API router. And I'm mounting that router here. I'm mounting the API router at /API. Yep?
On those routers, can you set context like put my gets to this router, put my delete to this router?
Absolutely. And we're gonna absolutely see that. In fact, you know what? I'll go ahead. We'll just live code that instead of copy and paste. We'll say API router get. Actually, it's post, right? I'm posting this user. Post users. Right, that's the API I'm coding to right now. I'm doing, Yep, I'm posting to API users. So I'm going to say post users, and I'll give it a handler. And give it a method right there. Right? So for the moment, I'm not going to really put anything at that method. We'll just throw this here. So I think that's a really good question because it gave me a perfect segue into what I was about to talk about. So John, you can decide what you want there for that. But for my vote, that's pretty good question there. Oh, whoops.
Do those routes auto add the optional / at the end?
Sorry?
Do the routes add the optional / at the end?
No, you don't. And I also need a user object, sorry, here. So let's create a user object, new package models,
The new Java object.
new Java class, user.
Yep. Then you got page up.
Yep. Now I mentioned that Vertex makes it really, really easy to marshal POJOs back and forth using Jackson. In our case, though, because this API sort of expects what I consider to be a little bit unusual format, I put a helper method on this thing called toConduitJSON so that it wraps everything in that user. But yeah, you don't need the trailing slashes. So now we've got registry user test. Everything should be running here. We can run our registry user test. Let's see what we get back. We're going to get back green. We don't get back green.
Wah, wah, wah.
Wow. Yeah, and actually, so just in the nature of time, I knew that was going to happen. So see, we didn't get this thing called token back yet. And so we're going to do a little literary thing here called foreshadowing. We'll just comment. We'll just for the second, we'll just return a token. We'll set our token here. And why are we setting a token here? JWT. Because we're going to talk about JWT authentication. Right.
Now if we run that?
Now if we run it, we should get green, right? We have green, right? So we've completed our first step. But let's test it here. Let's come down here and say redeploy. All right, so we redeployed it. Let's test here. Let's go to register. And we'll push that in there. And it says hello code 1, right? So what's going on? I'm passing one test, I'm not passing this one. Right, so in our redeploy script, we're still spinning up. We're still spinning up our main vertical, right? Because we need to change main vertical. I don't actually want to serve websites from there now. I want to use my router instead. So what I'm going to do here is I'm going to say Vertex deploy vertical, new HTTP vertical. Because we deployed this originally inside of our test case, right? I didn't change this vertical. So my redeploy should have redeployed. And now I get back.
Its own thread?
Sorry?
Is when you deploy the vertical, is it its own thread or is it the vertex managing?
Good catch. Another excellent question here. So, all right, good catch here. It is. This is spinning off in its own thread. So this is potentially problematic because this could go in another thread and die and not actually spin up. And I will show you how to fix that. All right, so yeah, good catch. All right. So we just saw two new Vertex modules. We saw Vertex Unit and the Vertex Web Client. We actually also saw Vertex Web because I just went through 2 steps. So when we created our test here, our test we wrap with the Vertex Unit runner. We send JSON in. We post the JSON using our web client, and then we do very normally kind of test stuff, JUnit test stuff. Creating a REST API, we also done that, so we'll just walk right through that really quick. Vertex Web is what we use to create our REST API. The key terms here are the routers, right? We created 2 routers. We could have just done 1 router, but we decided to create 2. That way we can still say our hello code 1 router. And then we create our API router. We attach the API router to /API, and everything with user star gets handed over to it. And then we serve our requests. How are we doing? Oh, wow. Okay.
13
All right.
minutes.
13 minutes. What's next on our agenda? Oh, quick architecture moment. You want to take a
So yeah, a quick architecture moment. Yeah, we saw this earlier, right? So what we've done is we've created this web front HTTP server vertical there on the left-hand side. We're now going to show an example where that then back ends that into the database client vertical on the right-hand side, but the intermediary is that event bus that we talked about a little bit earlier. And going back to that gentleman's question about threading, right? Each of these verticals are in their own thread, totally asynchronous. It's how you get that massive performance that some of the web test results that this project has published and how you're able to get there. So in the interest of time, we'll let Jeremy rock and roll with some new objects.
So we're going to do a persistence test, right? Because we are now going to implement our event bus, which is going to handle persistence. So a persistence test. Is that my persistence test? That is not my persistence test. Persistence test. Here we
That should
go.
be it.
Now, persistence test is going to look an awful lot like our other test, right? So there's not like a big trick to doing this. It's actually a little bit simpler because we're not spinning up a web client, but we're doing the same sort of thing. We're going to pass in JSON. JSON's going to be the payload that we use to go back and forth. In fact, we're going to expect, we commented it here. And you notice up here we're deploying one single vertical, just our persistence vertical. We're going to test these in isolation. What we're going to do here, instead of making a web call, is we're going to call Vertex, event bus send. We're going to send to this address. Can everybody see this okay? We're going to send to persistence address a message that we've built right here, and then our asynchronous result is going to do normal JUnity kind of stuff after that, right? So we've got to create this persistence vertical. Grab our persistence vertical. And this is all it takes to implement your event bus. It's really quite simple to do this. Load, yes. So the key things we'll see here, why is that not happy?
Package name at the top, maybe?
Yes, good catch.
No package name, yep.
Vertex code 1.
Conduit. Yep, perfect.
Okay. So we're calling start, and this goes back to the question you asked about executing its own thread. This concept here, a future, this is not a Java future, this is a Vertex future. It's non-blocking. What it's going to do is this future is going to return a failure or a success to the calling thread. So we will, in a second, we'll wire that main vertical up, and it'll check these futures to see if they worked, right? What we do, we're going to get our event bus right here, and we're going to create a consumer. And the consumer, we're just saying, call this persistence address right here. And then we're going to handle messages when they come in. Our message is going to have a key to it called action, and the action is going to tell us what to do. And we're just going to switch on that action, right? So we're going to say, in case that action says register user, we're going to call this method register user, right? And at the moment, we'll just fail it because we'll just do that first. So let's run our register user test. Let's run our other test.
How do the how do the other verticals? So is the question, are you asking how does everybody know that that event bus exists? It's just a common part of the framework that you're able to have there, and then you're basically using namespace of naming things as things are put onto that, and then other people are listening.
Other verticals create multiple buses out there, it's all the same one.
I don't know the answer to that one, Jeremy. Do you, John? If it's multiple event buses or if it's just one that everybody's sharing?
I thought it was one event bus unless you specifically create a separate thread.
Yeah, I don't know, but that would be my guess. Oh,
What am I doing? Am I running them? Yeah.
what's
I
your
got-
question, sir? Well, Jeremy's fixing a bug.
If the event bus works like a in-memory queue pops up,
I would say that that's a very good analogy for that.
so what happens when you have a flood of messages come and say number of people getting registered, and this is in a synchronous manner where we're creating those users, storing the database, suddenly application stops.
Right.
Is it stored somewhere that stays so because if there are in-transit users which needs to be still created, but haven't been created, what happens in that case?
Yeah, so the question you're asking is there a method for back pressure, if you will, on generating clients? And I don't know the answer to that one.
Yes, we're actually not going to show that today, but yeah, you can do that. And good question. Can we table that to the end? I'll discuss afterwards how we do that.
Yep.
All right, so the reason we were failing was because I said message fail on my initial implementation. We've now stubbed this out, right? So we're just stubbing out a little return value and replying with the value. And now we're sending that back, we're testing it, everything's happy. So we just completed that. How much time do we have?
8 minutes.
All right, so I'm going to go ahead and wire this into the front end without jumping back to slides. So what we're going to do now, this is what I mentioned, and you just asked about how do we know when we execute in this main vertical class, how do we know that everything's working okay? So here's how we're going to know. We're going to do this. So this is the Vertex concept of futures and composite future. First things first, this is what a future looks like. We have this future named deploy vertical. It takes in the name of a vertical and it deploys that vertical. And if we look here where it says event is our asynchronous event, if the vertical deploys correctly, the vertical is going to send back to the calling thread, yes, it worked, or I didn't. We're going to complete or we're going to fail, right? And we're going to call this 2 times, one for the HTTP vertical and one for the persistence vertical. We're going to wrap that in a composite future with an all method. And all this means is I'm going to send off these 2 other threads to go do their work. And when all of them have told me if they succeeded or failed, then I'm going to take some action. And I'm going to either succeed if everything succeeded, or I'll fail if any of them failed. Right? And so this allows us to spin up multiple different threads and then wait for everything to come back happy or not. So now we can spin this up. We can spin up both verticals, and we will go inside of our HTTP vertical, and instead of just turning that back, we will
Yeah, in the Vertex programming model, you could certainly set timeouts where things would then come back if they don't do something in the allotted time. That's definitely a part of this that's going on.
All right, so now the way we wire this in, we're going to just call our message bus, right? So instead of just stubbing it out, this is my HTTP method. In my register user method, I get my routing context that has my request. I just pull this JSON directly off the request, send this to the event bus, and then if it succeeds, I turn this back into my value, into my POJO. This is really simple. Vertex makes it really easy to take JSON and turn it into a POJO. I'm going to go ahead and set that token because we're out of time for foreshadowing and all kinds of drama. And then I'm going to send this back into JSON. So now I'm going to run my register user test. I'm calling my HTTP endpoint, and I'm going to expect that to come back correctly, which didn't happen. I got a 500 error. That's good. 201 is not 500. Great.
Something isn't wired up right. Is there a missing object?
So let's see, where's my HTTP vertical? This is my HTTP vertical. Oh,
you're
registry,
missing
no,
that.
here,
There's
this, no,
another-
here it is, here it is.
There's another.
I deployed just the HTTP vertical. I don't
Yeah.
want that. I want to deploy main vertical, right?
Yep.
There we go. All right. And now we have green, right? So now we tested all the way. We've gone all the way to the back. One more thing to do, though. We're not talking to a database yet. So let's go in and wire in our database persistence vertical. So right now, we're just stubbing this out, right? So let's go in, wire in actual stuff. We're going to grab 2 more Vertex modules. One's going to be called Vertex Mongo Client, and one's going to be called Vertex Mongo Auth.
And that Mongo Auth gives you some abilities. I'll let you type and talk about this a little bit. So the Mongo Auth bakes in some of the good hygiene that we do around password management, salting passwords. I'm not going to ask if anybody doesn't salt passwords in their organization. Hopefully at this point, after all the brutality across various hacks, that we don't do that any longer. And does some other things to manage the keys that are going underneath the covers that are going into, in our case, Mongo, to make that a little bit easier for us to just create a authentication mechanism inside of this application. Does it work with any NoSQL database?
So we have drivers for lots of different databases. It also works with traditional JDBC. We have a JDBC driver. JDBC, however, is blocking, but we kind of wrap it in a way that it doesn't appear blocking. Postgres has a non-blocking driver. Other
And MySQL does also.
it does?
Yeah, well, they say in the docs it does.
Oh.
Does it work? It should, based on the docs.
All right, so what I've done, I've just instantiated these 2 clients, and I'm going to configure my client, Mongo client, how we're configuring it. This looks pretty simple stuff, right? Our configuration is a JSON object. We pass in JSON for configuration. We're just giving it the name, a database name, conduit code 1, connection string. This is another module I'm not using called config. What config is doing is that you can set config to look on the file system, to look at environment properties. If you're running like an OpenShift or Kubernetes, you can look for a config map. It can grab that configuration change. If it doesn't find it, it defaults to this. So that's my default, right? So I don't have config set up, so it's going to say, do I have config? Nope. I'll just use this default, right? Makes it really easy to use configuration. The login auth provider, spin up pretty easy. I give it my Mongo client so it knows how to talk to Mongo. And now let's just grab this method. Register user is going to look a little bit different now. And I'm going to do this in 2 steps, roughly because of what Jim just mentioned. And this was a little funny. So the login auth. Oh, one thing to notice: the login auth. Normally, we assume that username, it's going to use username and password. In our API that the Conduit guys created, we use email and password. So I'm just telling it to use email instead of username here, right? So we have set email name and set credential field. So I'm doing that. But I'm going to use the login auth provider. I'm going to insert user, and I'm going to give in the email and password. It's going to salt off and encrypt my password. I've actually got Mongo running right here. Let's say show deep. Why is my font so small there?
Different window.
Oh yeah, okay. Use. I'll just delete this DB drop database. All right, so I just dropped the database just so we know this is actually working. What this does, I'm going to insert this user. The result of that, it's going to give me an asynchronous result. That result will be the ID of the newly created object. And then I'm going to make a query. This is an interesting format. Our queries are all JSON objects. So we create JSON for our query. And what I'm saying here with query is tell Mongo, where ID equals this. And then my update, this is Mongo syntax, right? Set the key value pairs in this JSON, right? So I don't have to write out SQL. I just use the key value pairs from there. That's going to put it in the database. It's going to set everything back, and then it's going to send the response back. So now let's do register user, run our test again, and we went all the way, we round trip to the database. So register user, let's go back here. Whoops. Yep, let's stop that. Let's start that. Redeploy.sh. And I'm coming back. So now I'm round tripping to the database. I want to check the database. I probably have 2 users in there right now. So use conduit code 1, show collections, DB user find. I've got 2, and you can see where it has salted the database, right? It put a salt in the database, and it hashed the password, right? So it takes care of that really easy for us. Are we done now?
We're done, but let's do the JWT.
Do you guys mind if I hang out for another minute for JWT? All right. Yeah? Yeah.
Quick question, I noticed you're using Java 1.8. Does Vertex support 9 or not?
We're not officially supporting 9, but John, do you know if it runs on 9?
Yeah, I think the team's already got 9 support upstream in the Vertex project, and you know, we're going to work towards 11 as well. So that should be there. So it's on the way.
Yeah. Could you say that again a little louder? Reactive?
Yeah, for example, this is like to the MongoDB. I have a query, will return 10,000, maybe column. I don't want to wait for the call that 10,000 what? I want stream.
Right.
Yes.
So the question is, if you had 10,000 results coming back, what do you do? And Jeremy, what would you do?
A couple of different approaches, right? Obviously, we can paginate. We also, RxJava, we're not showing it in this demo. RxJava is built into Vertex, so you have full access to all kind of the APIs inside of RxJava, which I can show you after this talk. I can show you an example of what that looks like. Really quickly, I'm adding Vertex auth right in here, auth JWT. Add in our new dependency, save that off, and then we will add a JWT auth to our HTTP vertical. Because part of what we were showing in this talk is, although you can do a lot of advanced stuff with Vertex, you can also just build pretty simple websites easily. There's a lot of really nice stuff in here just for doing what's pretty traditional website design. So inside our JWT auth, we'll configure our JWT auth here. We need a key store, which I'm going to go ahead and cheat and have a key store here on my desktop right there. So in case you don't have in case you don't have a key store lying around, these things are easy enough to generate, just using the JDK, right? Put it in the main source. Paste key store into there. So now I have a key store that I can use to generate tokens. And then now we will do this token. So now our token, instead of just insert token right here, we're going to call our JWT auth generate token. We're going to give the email and the password to the token. That'll be hashed as part of the token. And then I'm just going to set on my options, I'm going to set ignore expiration because that's fine, right? And then I'll just set that token onto the user and return our response. Let's test this to make sure it works. Register user test. What are we doing? We're saying not null tokens. Let's do this. Instead of saying not null, let's say that assert true, get string, key token, dot length is greater than 25, right? So I'll say this should be long. So now we'll register our user. And we passed. Let's come back to and we'll post this. And now we're getting back an actual token right in our result there. Can you guys see that? Can I zoom that? So we're getting back an actual token, right? And it says time is now up. All right, so time's now up. Yeah.
We do a few questions after this, but we probably have to cut off our microphones. But you guys are welcome to come up for this. For all those who ask questions, feel free to come up. We'll hand out the prizes and get a book ordered based on
this guy's
thing. And thank you all very much for your time at the end of a very long week.
Yeah. Thanks a lot, guys.